Dear students, today we are going to discuss about the battery and electromotive force. Before going to discuss the battery and its electromotive force, let us take one example, in which pump lifts water from the ground tank to a overhead tank. This is a very interesting example, dear students. This is a overhead tank and this is a groundwater tank. Water flows from overhead tank to groundwater tank by itself due to gravity. But to flow water from groundwater tank to overhead water tank, some pump is required or some external work has to be done on the water. This is the flow of water from overhead tank to groundwater tank. It flows under gravity. No external work has to be required. Whereas to flow from groundwater tank to overhead water tank, some external work has to be done or pump is required to flow water. Similarly, when such a resistance is connected across the terminals of the battery, potential difference takes place across the terminals of the battery. This is a positive terminal and this is a negative terminal of a battery. There is some potential difference between these two terminals. The same potential difference is developed across the ends of the resistors of resistance R. So the current or the charges are freely to move from positive terminal to negative terminal of the resistance. The end of this resistance is at positive potential, the end of this resistance is at negative potential. The flow of charge takes place from positive terminal to negative terminal on its own, that is due to potential difference. Whereas within the battery, this is negative terminal and this is positive terminal. The current flows from lower potential to higher potential. We know that current always flows from higher potential to lower potential. So this is the higher potential point and this is the lower potential point. So current flows from higher to lower potential point on its own. But whereas inside the battery, it has to move from negative terminal to positive terminal, negative terminal to positive terminal. We know that current always flows from higher potential to lower potential, but whereas within the battery, it has to move from negative potential to positive potential. So to move this current from negative potential to positive potential inside the battery, some work has to be done by the cell on the current. Some work has to be done by the cell on the current. So the work done per unit charge when the current moves from negative terminal to positive terminal of the battery is called its EMF. Okay. Current flows from positive potential to negative potential in the external circuit. But inside the cell, it has to move from negative terminal to positive terminal. So some work has to be done by the cell on the current to move it from negative terminal to positive terminal. So let Q is the charge. Let Q is the charge that moves from negative terminal to positive terminal. In unit time. In unit time. The work done by the cell. The work done by the cell in moving the charge Q, in moving the charge Q is W. According to the definition, the work done per unit charge. The work done per unit charge is called EMF, electromotive force. This electromotive force is denoted by E. So E is equal to work done per unit charge. W is the work done in moving a charge Q. So per unit charge, the work done is W by Q. So electromotive force is defined as work done per unit charge, and its unit is joule per coulomb. Which is called volt. So potential difference and EMF have same units, that is volt or joule per coulomb. Okay, this is about the definition of electromotive force.